Okay, let's go to LeetCode 528 random pick with weight. For this question, it gives us a weight array. It let us to randomly pick the index from the weight array. And based on the random should have the weight as a factor to be considered. So let's take an example. For example, we have a weight array. We have, for example, the first weight will be 1, the second weight will be 3, the 4, and the 1,000. And in this case, we'll see for the index 0, it will have a weight 1. So we can assume, for example, it appears once. And the index 1, it will have weight 3. So let's assume index 1 will appear 3 times. And the index 2, it has weight 4. So we'll say, let's assume that 2 appears 4 times. And the index, let's have 3, or we'll say n have the weight of 1,000. So this 3 will repeat 1,000 times. So intuitively, what we're thinking about, we can generate a list like this. And for example, this list, it will have the size, it will have how many elements, it will have, because for 0, we use one, it appears once, in 1, it appears 3 times. So for this element, for this list, there are totally 1 plus 3 plus 4 plus this number of elements. So intuitively, what we think about is that we can create a random number. This is random number from 1008, right? Yeah. So this will go randomly picking the number from 0 to 107. So we use this random number trying to have, for example, this list. And we use list get, and it will get randomly pick a number from this list, then return this. This will be our result. But this kind of approach, there is a problem because it says that the weight array has a length in a range 10 to the 4th. This kind of range, and also WI has 10 power 5. So it's possible that our list will have 10 power 9 elements. In this case, this will be, I think it will be out of 10, will exceed our time limit. So we should have a better approach. So what are we thinking about is that we know for the first index, it appeared once. So we can create some other kind of data structure. For example, as the first index, it appears once. So we'll say we can put this one here, and we'll say this number, the second index will appear 3 times. So we know the first element will be this, and the first 4 element, let's see, because we added this one, the first 4 element will either be 0, index 0, or index 1. So we look at here. So that will be the first 4 elements. And also we'll say the first 8 elements. It has 3. It can be the index 0 and 1 or 2. So this we have first 8 element. We'll say for the we can create a prefix sum. That is data structure. Let's say the first element, it has index 0, and the first from the prefix sum, I say the second to the fourth, it will have the index 1, and from the fifth to 8th, it will have index 8, and from the 9th to 1008, it will have the index 3. So we can create another structure called the index prefix sum. And now what we do is that we also still we get this number and get this random out. And in our prefix sum, we say this prefix sum is always increasing. We will trying to find, for example, this random number, the first number which were bigger than this random number. You can see random. So, for example, if this random we get 0, we in this prefix sum we find 1. That means we pick the index 0, and if we have a random number, for example, we get 2, we find the first one which in this prefix sum which is bigger than 2. We find 4, right? The 4 is the second element in our prefix sum array. So we will say its index let's say is 1 because we are starting from index 0. And for example, we will get randomly we get 500, right? 500 is in this range. Then we find the first in the prefix sum, the first element which is larger than 500, we find that is 108. 108 in this array, its index 0, 1, 2, 3. So that is 3. So in this case, we can use some kind of binary search to find the index. So let's write a code. I'm going to create a prefix sum array and also a random number called rand, and I'm going to store this n because this n once we give the weight array, the n will be fixed. So we are right here, n equals weight dot ends. Let's create a prefix sum array. Normally, For me, I prefer to have one actual length of the prefix sum. I'll have the, for example, new int n -1. For this question, I'm going to keep this kind of style. Of course, for this question, you put int n, it is fine. But sometimes we use the prefix sum trying to calculate some kind of range of the subarray. Use actual will be much easier. For int I equals 1, I smaller than n plus 1, I plus 1, and the prefix sum I equals prefix sum I minus 1 plus weight. And also we need to create a random number. Okay. So our next thing is that we are trying to implement the picker index. So now let's iterate this prefix sum array. Let's repeat here. We add actual 0 at in the front. So we'll say we should create a number which will be randomly from 1 to from 0 to 107. So I'm going to get the prefix sum max out, the max number, the last number out. We call it max. Max equals the prefix sum n, and I have a number called a random pick. It will be random next int max. So now we'll say so now let me see. So now we randomly get this number, and our start will be, for example, we are trying to do the binary search for this prefix sum. Start will be start from here, and be here. So let's have the start to be index 1. Int start equals 1, and end equals n. So let's write the binary search. We are trying to find, for example, the first number. For example, we have a random pick that is 3, right? The first number, first index, which is greater than 3, that is 4, right? So this index in our prefix, it is the index. Let's write the index. the index, this is the index 0, 1, 2, and 3, right? So our first index in our perfect sum will be 2. So we'll be find 2, right? So, but we need to, this is a perfect sum, we add extra. So we'll just find this index, then return this index -1. So let's write binary search, because we want to find the first, that's right, binary search, find the first index in prefix array greater than the random picks. So let's try it. While start +1. Let's say this index, it's the let's put something. Index in prefix sum array. It is one number shift than the original array. So when we return, we are -1. So let's write a binary search while start +1 smaller than end int mid equals start plus and minus start. So we are trying to find the first index greater than. So if prefix sum mid, I say if it is small, equals to random pick. That means the first greater may start on the left. So that is we'll have end. If this is equal to sorry, if this is equal, we'll find the first bigger, right? So I would say this middle, we should shift to the right. So I say start equals middle. And if this one is also, if this one smaller, right? We also have a start equals to middle. Then else and equals middle. So we are searching the index. Right? This index is we are searching in the prefix prefix sum, and this one has one index shift to the right. So they're trying to say if prefix sum, because we are trying to find the first start already bigger than random pick, then we are return start -1, right? And then return end -1. So for this question, we create a prefix sum. So then do using the binary search. We'll say if there are n element in the weight array, every time our as in the constructor, we have an operation to create the prefix sum, and in every pick index call, we'll do a log n operation to find the index, because it is said that the pick index will call at most 10 power 4 times. In this case, the time complexity, it will not exceed the time complexity. So this operation is log n, and this initialization is O(n), and we have a prefix sum array called being created here. That is the O(n) space complexity. So let's sum it.